I'm going to talk more today about technology, about the history of Tesla, how we got started, and some of the technology trends that let us get started, and then also are still accelerating in the industry today. And a lot of these things, in my view, in our view, are going to have a profound impact on the overall energy industry. This is an interesting period in time. There's new technologies coming that are fundamentally changing and undermining a little bit the utility business model and causing more change in the transportation business model in general than people have seen in many, many decades. So maybe just as a recap, what is Tesla's goal? A lot of people think of Tesla just as a car company, and they think, our goal must be just to make and sell a lot of cars. But that isn't really why we got started. It isn't why we founded the company in the first place. The world has a lot of cars. We didn't really think it needed more cars. We started the company to accelerate the overall transition of the world to sustainable energy, both for transportation and on the grid. And it's a wide-ranging goal. It's a massive goal. But why we felt this was so important is largely because of the atmospheric CO2 problem. This is a graph many people have probably seen many, many times. But it's what really speaks to the urgency, in my view. Why it is important to actually accelerate this change. Why we can't just let it happen at its own pace or leave it to other governments, leave it to other companies. And it's why we felt a personal urgency to dive into this problem, to rally around it. Just recently, this graph is actually a tiny bit out of date. Just recently we've passed 400 parts per million of CO2 in the atmosphere. And it was a milestone that didn't get a lot of fanfare. You didn't read about it on the front page of many newspapers. But that's an interesting milestone. We can measure it in the air outside this building, in the air inside this room. This is something all around the world that has changed. And we're not going to see it go below that, most likely in any of our lifetimes. That's a pretty phenomenal and profound change. And part of why this is so relevant is because of its impact on temperature. And this is an interesting visualization that I like that a climate scientist named Ed Hawkins did. It's watching kind of the temperature data over the last little more than 100 years. And you can see it spiraling out. As you go closer and closer to the present, you can see the temperature getting hotter and hotter. And it's really interesting seeing what's happened just in the last few decades. This is sort of amazing. And if you look at it on a regular graph here, you can see it even more directly. 2016, you probably have read, the recent months this summer have been some of the hottest on record that we've ever had. We've broken records every single month. And it's a little startling and maybe a little bit alarming, I think, just how far out of the norm that is. And I don't think there's much debate at this point that this is directly linked to CO2 concentrations that have increased as I showed in that previous graph. And the reason for those CO2 increases is because of our burning of fossil fuel. These things are all sort of chained together and linked. In the energy industry, both electricity, transportation, heating, this is at the heart of that. So the energy industry has created enormous prosperity and wealth and convenience and comfort for all of humanity. This is something that's done a ton of good for the whole world. But we have this opportunity now and this sort of mission in front of us that we have to figure out how to do all the things that have made us so successful for the last century without emitting CO2. So as an engineer, to me, that's this amazingly fun challenge. We don't get too many times when we have an opportunity to reinvent an infrastructure that is so big. It's a business opportunity, it's a fun technical challenge, and that's really what Tesla was founded to dive into. So back in about 2004 is when we got started. This wasn't that long ago in the grand scheme of things, but the landscape in the auto industry and the energy industry was quite different back then. There were really no other electric vehicles. No one was talking about electric vehicles. There had been an early wave of electric cars that were tried in kind of the late 90s, and pretty much all had failed. And we were coming into this space at a time when this was kind of seen as a completely crazy idea. Starting a car company, doing electric vehicles in Silicon Valley, it was not something that was the normal route. And it's very hard to find investors, very hard to find supporters at all. But there was one key technical advantage that let us get a toehold and let us actually make products that were compelling. And this was the change that had happened really in the last 10 years, since the late 90s to the mid-2000s, where lithium-ion battery technology and battery technology in general had improved so much and so rapidly. And if you look at where the last really earnest attempt to build a pure electric vehicle happened, this was with General Motors, the EV1. Some people might remember that car. It was a great car. GM did a fabulous job engineering that vehicle to be extremely efficient and to make the very most that it could of the day's technology for batteries. But the best that could ever do was maybe 100 miles of range, just a little bit more. And that was just not enough for consumers. It ended up being a market failure. And the reason that the whole industry was kind of written off was because they just assumed that was the best that you could do. Technology wasn't ready yet, and people kind of forgot about it for 10 years. Well, when we came and looked at building the Tesla Roadster about 10 years later, battery technology had almost doubled. It had gone from in the range of 300 watt-hours per liter up to about 600 watt-hours per liter. So that means you could store twice as much energy in a unit of volume, and you could basically get twice as much range out of your car. So what used to be 100 miles could suddenly leap to a little over 200 miles. And that made the fundamental difference. That shift was enough to suddenly relaunch the electric vehicle movement and to start a whole shift of the automotive industry. So at Tesla, our first product, and where we got started was with a small sports car we called the Tesla Roadster. This was the first lithium-ion production car that was put out there to consumers. And there were tons of naysayers. This was a really difficult innovation to try and get to market. We were essentially at that time commercializing consumer electronics, laptop technology into the automotive sector. Most people thought this was crazy. Why would you put laptop battery chemistry into a car? Can't be safe. It should never be there. But after a lot of hard work and software and development around the battery systems and control systems, we proved that it could be very safe. It could be very robust. And this started a shift in the automotive industry. Today, if you go to an auto conference, here or on the West Coast or anywhere overseas, you'll see electric vehicle offerings, from just about every single manufacturer, whether they're plug-in hybrid, or full electric. Almost all of those are now using lithium-ion batteries because of the compelling advantages in energy density and also cost. And we didn't stop with the Roadster. Most people didn't really hear about the Roadster. We only built a few thousand of them. It was a relatively tiny volume car, but it got a toehold for us. What we did after that was much more groundbreaking. The Roadster was in some ways for us a conversion. We took an existing car and we put a battery inside of it and put an electric powertrain in it. But after that, we started from the ground up. And this is something that I think is a good lesson for the whole alternative energy industry and sustainability industry. When you're trying to convert something into a more efficient or a different technology, there's fundamental limitations. And when we were able to start from a clean sheet of paper with no existing design, we could optimize things far more. And it resulted in a very different outcome than many people expected. We literally didn't have a rule book. We'd never built a car before. So we could look at the fundamental technology of what makes up an electric car and build up a whole set of technology around that and build a vehicle around that. One interesting thing is that we built a car essentially around the battery pack. That flat sheet on the bottom of the car, that is the battery. It sits in between the wheels. It ends up making up a lot of the structure of the car. It carries a lot of weight. The whole weight of the car is really centralized very low. And that gave it incredible handling. It gives it good braking performance. And these are characteristics that any electric vehicle can have. It's not unique to Tesla. This is something that we're the only ones doing it in this way right now, but it doesn't need to be unique to us. It's fundamental that any technology, car using electric technology can end up having these same advantages. And I think the results in the Model S have been surprising to the whole industry. Most people didn't expect that this first new car from a new company would be able to compete effectively with Mercedes and BMW and Audi and brands and cars that have been around for 100 years. But fairly quickly, this vehicle rocketed in sales and popularity, and we've been able to set a lot of superlatives in the whole industry. Today the Model S is the fastest accelerating production sedan on the planet. And that's pretty amazing that new technology has gone from being totally uneconomical less than 10 years ago to being one of the fastest accelerating cars you can possibly buy today. It's also the safest vehicle, the highest safety rating of any vehicle. And that's not just related to the design of the car, it's fundamental to the technology. We don't have to have big engines in the front of the car, so the crash structures in the front and the rear can be optimized to absorb impacts much better. Also, finally, we have over 300 miles of range in this vehicle. The battery technology has kept improving year on year, and today we're having range that really rivals gasoline cars. That's not the big limitation anymore. The biggest limitation is cost. Most people don't want for more range, they don't want more performance, they don't want it to be bigger, they would just like it to be cheaper. So a lot of our work goes into how do we take the same performance and the same advantages we have in this more expensive vehicle and drive down the cost of all the basic technology that goes into it. And we also innovated a lot on some other areas that weren't focused around energy as much, but have come to be really quite important, I think, to the industry and also to our brand. And coming from Silicon Valley, to us it was sort of natural to integrate consumer electronic type technology into the cockpit of the car and into the user interface. We're sort of surrounded by companies that are doing touch displays, and whether it's in a phone or a computer or things like this. And it, again, felt natural to us to just incorporate all that into the cockpit of the car. Instead of making a whole bunch of plastic buttons and knobs and things like that, we took a very different course. Everything in the car is on a flat panel display. The whole interface from the user to the car is via touch. And also, all of that is controlled by software, which is a pretty different experience than you might have in a lot of other vehicles today.